All right, so for this question, the first place I want to point you, in case you're lost, terribly lost, is to go to homework 5, question 24, where I explain how to graph 9 to the x. But we know that 9 to the x from that thing, that video, if you go watch it, it goes through 0, 1, 1, 9, and negative 1, 1 over 9. So it's a graph that looks approximately like this. It has a horizontal asymptote right there at y equals 0. All right. And it goes up through those points. All right, so in math, we have inverses for everything, right? When we do 2x equals 4, we divide both sides by 2. When we have x minus 2 equals 4, we add 2 to both sides, right? These are inverse operations. Same thing when we have x squared equals 25. We take the square root of both sides because that's the inverse. The opposite of squaring is the square root. So what I'm saying here with all of this is that if you have 9 to the x, its inverse is log 9 of x. All right, that's how you get from one back to the other. All right, and so in a real simple way, I know that if this is 9 to the x going this way, if this is 0, 1, negative 1, 9 to the 0 over here means 1. 9 to the 1 corresponds over here to the number 9, and negative 1 corresponds to negative 1/9. So what I'm saying is if I take log 9 of 1, I get back to 0. Right, now I go back the other way with it. I go back over here and go from 1 back to 0. And log base 9 of 9 is going to be 1. Right? It's how I get from 9 of x is how I get from the numbers on the left to the numbers on the right. And log 9 will take me right back to those numbers. And that's what an inverse really means. And what this really tells us is that the xy relationship is flipped. Right? For 9 to the x, all these x's here became y's over here. Right? These became y's over here. But now what I'm saying is now I'm going to let these y's become the x's. And the output of log 9 is going to be this y over here. So we're just flipping that relationship. Now from this video, we realized that every exponential function goes through 0, 1, 1a, negative 1, 1 over a. All right, and we have a horizontal asymptote at y equals 0. All right, that happens to every basic exponential function. All right, so what that means is if I'm doing an inverse, all these xy relationships flip. All right, so for a log, I go through, instead of 0, 1, I go through 1, 0. Right, the x becomes the y and the y becomes the x. I go through a, 1, and I go through 1 over a, comma, negative 1. And instead of being horizontal asymptote at 0, now I'm going to have, instead of, what's the opposite of horizontal, the inverse of horizontal? It's vertical. I'm going to have a vertical asymptote at x equals 0. All right, so what that means is, first thing I want to do is draw in my vertical asymptote right here. All right, so I draw that in. All right, now I've used the generic base a. We see our base over here is a 9. So I go through 1, 0. It's right there. A, 1. So a, if the base is a, and our base is actually 9, that means I go through 9, 1. So I'm going to go over 9 and go up 1. So I go through that point. And then I go through 1 over 9, negative 1. So I'm going to be really close. And so this graph then does something like this. And that's what the graph of a log function looks like. And now another neat point here about inverses, that's something that's not unique to this section. It's true of any inverse function. It doesn't matter what it is. If you draw a line right diagonally at a perfect 45-degree angle through a graphing grid, these two graphs are perfectly symmetric from one side to the other. It's like a mirror image. So if I take the black line and do a mirror image about the green line, I get the purple line. And so inverses are always that way. When you take that line, the inverse graph should look like a mirror image along that green line. And that's how you do graphs of logs. But again, it's very important to understand what's being said in this video before this one makes a whole lot of sense. So go review that one if you need to.